today we're going to finish section 2.3, and we left off having done one example last time of shading diagrams. You guys remember doing that? Yes. We put some numbers in there, and we did some unions, intersections, and we shaded the results when we were done. And I believe that maybe we did two of those. We did two of those? No, maybe we did. Tell me. Yeah. We did two of them, right? So we did example 2A and B, and then we did 3 of them. Look, we did example 3, and we did all 3 of them. Okay. So we're on this one, example 3. Example 3 says to draw an appropriate Venn diagram and use the given information, which I'm going to give you in a minute, so just hold tight, to fill in the number of elements of each region. So here's the pieces of given information that you need. You need that N of A is 24. N of B is 24. N of C is 26. N of A intersect B is 10. N of B intersect C is 8. N of A intersect C is 15. N of A intersect B intersect C is 6, and N of U is 50. So I start with a rectangle, and how many circles do I need? 33. There are 3 circles. Whoa. I showed you guys how to do cloning like last time or time before, right? Let me show you how to do infinite cloner, because this one's fun too. So we're going to click on this one on the right hand side. I'm going to click infinite cloner. What this allows, has anybody seen this before? No. What this allows me to do, oh, that was not what I was supposed to allow me to do. Let's try that again. Okay. All right, so it's got a little infinity up here. It allows me to take my image. Well, I said it did. There. And I can create lots of them. So it's kind of like it's a copy that holds, like sticks to it. And then I can move, once it's infinitely cloned, though I can't move it. I have to turn the infinite cloner off if I wanted to move the object, the original object. With these, I can move. So there we go. All right, I need to label them what? A, B, and C. And I need a U. Where does U go?
Outside.
On the outside. Perfect. You guys are very vocal today. It's so polar opposite from my 8 o'clock, my 9 o'clock class. I won't stop reading here. Okay, here's the deal. When you've got a diagram like this, you're supposed to be filling in all of the 8 regions. We talked about the back last time. There are 8 regions. And what we're going to be filling them with is the number of items in each of them. Now, the problem is that if you just start with N of A doesn't mean this outside piece of A. It means this piece of A, and this piece of A, and this piece of A, and this piece of A all add up to 24. So you don't want to start there, because you've got 4 pieces and we're going to be guessing and checking all day if that's where we start. The same problem holds for N of B or N of C. So then the next piece of information intersects things. But that's not going to work so well either, because A intersects B, again, in 2 locations. So I don't have quite as many options, but I still have 2 options. And if I'm going to do guess and check again, I'm going to be out of a while, unless I'm just incredibly lucky, and I usually am not. So we're going to be out of a while. So we want to start with the most detailed, specific piece of information that we have in the problem. And in this problem, that piece of information is what?
The middle.
The middle. Yes, and it's not always the middle, but often it is.
6.
It's the 6.
You're so smart.
Good job, Cherish. So the 6 goes in the middle, right? Like so. Once I've got that piece stuck in place, all of the ones where we intersected 2 sets, I can get pretty quickly without any guessing and checking. So let me go backwards, and I'll just go backwards on my list of numbers here. This one's A intersects C. So A intersects C where my 6 is and where this blank spot right here is. And those 2 have to add up to 15. So what goes right here? 9. So we do have to add and subtract, right? Okay, good. So we've taken care of that one. This one is B intersects C. So B intersects C in these two spots. One of them is 6 and the total is supposed to be 8, so I need 2. All right, I move backwards again. This is A intersect B. It's 10, right? So these are my 2. 4, very good. You guys are going to speed ahead of me now. All right. Now I can deal with the C, B, and A individually just fine, because each of the circles only have one piece missing. So let's just start with A. So A is 24. So right now I have 4 plus 6 is 10 plus 9 is 19. I need 5 more. B is 24 as well, and I have 4 plus 6 is 10 plus 2 is 12. I need 12 more. And C is 26, and I have 6 plus 9 is 15 plus 2 is 17, so I need 9 more. Yeah. Okay, so far so good? What's missing?
U.
Well, I haven't used the 50, and I need the part on the outside that's U. So obviously I'm going to go find those pieces. In a view, that's the universal set, right? It means everything in the whole picture has to add up to 50. Right now, I don't know what I have, but we should be able to take ourselves and add these up pretty quick. I know this is 24, because this whole circle A was 24. So I have 25, 26, 36, 37, 38. 38 plus 9 is
47.
47, which means I'm missing 3. There's 3 on the outside. Make sense? So the way you want to think about this is starting from the inside and working out. Kind of like a parentheses, right? We start from the inside and we work out to build a diagram. And we want to be able to do that to do a problem like number 4. Got a couple of them. Here's another one. So we don't have numbers given to us with this math notation of intersections and unions and this kind of stuff going on in this problem. Instead we have a word problem that relates that kind of information to us, right? It says we have Joe Long and he worked on albums for musicians. Last year he worked on 12 projects. He wrote he wrote and produced 2. He wrote 5 and he produced 7. And I've got some questions after that. The whole idea is for us to create a Venn diagram so that the questions are really obvious and easy to answer. Okay, so the first question I need to ask you guys is, how many circles do I need in this Venn diagram? 2. All right, so let's start there. What are the circles going to be labeled?
Wrote.
Wrote and produced. And what piece of information is the most helpful to start with?
The middle.
The middle, which tells me is the 2 that he wrote and produced, right? He wrote and produced 2. So it goes in the middle. But he wrote 5. Tells me I put a 3 out here, right? He produced 7. So we have 5 more out here because 2 plus 5 over here is 7. And then I didn't write the U, but I could. This is the universal set. How many have to go on the outside? 2. Why are there 2 on the outside?
Because that only has 2 in the middle.
Right, there's only 10 right here. And the problem said he worked on 12 of them. So maybe he's staying on the other ones, or maybe he did marketing, we don't know, but he did something else for those other 2. Okay. Now, once the diagram is complete, the questions become really easy to answer. Right? First question, part A, how many projects did he write but not produce? That's 3. The outside part over here. How many did he produce but not write? 5. And how many did he neither write nor produce? 2. Easy questions once the picture's done, right? Yes. The youth group was asked questions regarding songs that they had learned as children. Upon surveying the 34 youth, the following results were obtained. 15 had learned Jesus Loves Me, 18 This Little Light of Mine, 28 the VIBLE, 13 Jesus Loves Me, the VIBLE, and so forth. So we've got some overlapping things and whatever. At the end, 13 had learned all three. And then we have some questions. How many children had learned exactly one of these, at least two of these, none of these, and This Little Light of Mine, no others? Now, if you try to answer those questions straight from the information given, that's a mess. If you draw the picture for it, it isn't. So we're going to draw a picture. And what will my picture, or I should say my diagram, how many circles will my diagram have in it? 3.
What's the same example? I remember this. I just
It's actually from a test that you took, Kayla. It is. See, this is what you do when you teach, is that you steal stuff from yourself. Yeah, that's allowed though. All right, what are my 3 circles?
And Jesus loves me.
Right, Jesus loves me, so I'm going to just write Jesus. Is that okay?
Light. Yeah.
And then this little light of mine, I'm going to write light. And then VIBLE for Bible. Do we know these songs? Yes. I know them really well because I have kids right now. Right? So it comes back to haunt you if you work with children or have them. So you know the songs well. All right, so where am I going to start with the picture? Middle. In the middle. And what numbers do we go in the middle?
13.
13.
Beth is really excited about this.
She is excited. That's fun. Yeah. All right, we got 13 in the middle, and you know what? Here's what I'm going to do. I'm going to mark them off as we've used it.
Yeah.
Okay, so we did this one already. Now we have 14 had learned This Little Light of Mine and Jesus Loves Me. So that's my top, and the 13, which means how many go right here? 1, because it's supposed to be 14, right? All right, the next one. 15 had learned This Little Light of Mine and the VIBLE. So that's the right-hand side quote.
Is it 2?
Yes, it is. All right, so there's my 2 right there. 13 had learned both Jesus Loves Me and the VIBLE. So I need a 0 on this one, actually, yeah? It's okay, we can have zeros. We can have negative numbers, but we can have zeros. All right, 28, I should say had learned. That's a good typo. Oh, I tried to use blue and I got both my hands not work. All right, so 28 had learned the VIBLE. So down here, I'm supposed to have 28. Well, how many do I have right now? 15, which means I need 13 more to add up to 28. 18 had learned This Little Light of Mine. Yeah, there's 16, so I need 2 more to make 18. And 15 had learned Jesus Loves Me over here. I'm missing 1. So do not be like my contemporary math students that just took this on their test about 2 weeks ago and leave this unfinished. There was 34 of them, right? So did I account for all 34? Not quite. How many do I have that? Did you have that yet? No. How many? 32? 32 too?
Oh, I didn't finish it.
Okay. I've seen several people said 32, so I must be missing 2 folks, right?
Yeah.
So these are the children who are evidently raised, I don't know, in the Middle East or something, right? I mean, maybe. Right? I mean, like, if you have popular culture, you typically have heard of one of these songs. But 2 of these kids have not. So, I mean, like, in the Middle East, they have a Muslim family or something. Okay? So they have not heard these songs before, these 2. All right. You guys ready to answer the questions?
Yes.
They should be easy to answer once we drew the diagram. How many have learned exactly one of the songs? 16. Which numbers did you add up?
1, 2, 13.
Right, the 1, the 2, and the 13, they're on the outside. So there's 16 of these. How many had learned at least 2?
16.
It's also 16, but you didn't add those numbers up the same way, right? What numbers did you add?
1, 13, 2, 0.
Right, these 3 or 4 rather in the middle. So I had 1, what do we say, 2, 13, and 0. So it happens to also be 16 that have knew at least 2 of these. How many knew none of them? 2. Are 2. And how many have learned? What did you guys say? How many have learned the still light in mine and none of the others? 2. That's right.
You like that?
I guess. Okay, I think we have one more slide, yeah?
Yes.
Let's take a break.
Hold on.
I went back. Okay.
The Middle Eastern over here.
Okay. We're having way too much fun just getting that stuff, right? Okay. Can I move on? Gosh, we just slow down.
Do not have too much fun.
Yeah, that's too much fun. Are we good?
No, she's still right.
Are you good, Kate? Chair? Are you good? Yeah? All right. 2 more examples, 1 slide left. Example 6. Okay, Cartesian product. We talked about that last time. Do you know what Cartesian product is? No. Can you go back to the slide for it?
Yes.
Okay. There it is. The Cartesian product is the set of ordered pairs. So the first component comes from the first set, and the second component comes from the second set. And your most common example that you've seen do this before is when you do your XY coordinate plane, and you do numbers and the points in the plane. Okay. All right. So we're talking about the Cartesian product over here. Is the Cartesian product commutative? Why or why not? So let's talk about commutative again. We talked about that last time too. What does commutative mean?
It's really like cool. It's really like we flip it.
Okay, so we can switch the order, right? So commuting is switching the order of something like 5 plus 2, same as 2 plus 5. The order doesn't matter for addition. So Cartesian product commutative. It is not. How come?
Because if you have like A, B, like A, like parentheses B, whatever, that, yeah, it's not the same as B, A.
When? When is it not the same?
But when you plot like a point of slopes,
There are some cases where it would be the same.
by being they don't equal the same.
That's right, Kayla. This is not true when A is not equal B. So if A equals B, it would be true, right? Sort of by default. Yeah, by default, right, Beth? So we would be switching the order of these, and as long as the numbers are actually different numbers, or the letters are actually different letters, when I switch the order, I get something different. And the image in your mind should be those XY points on the Cartesian plane that you've seen before, the coordinate axis. It's a different point, right? Yeah. So this is why they're not commutative. So you can't change the order and get the same thing. Example 7: a student argues that adding 2 sets and taking the union of the 2 sets is the same thing. How do you respond?
It's not adding, just the whole stuff, the whole together. It's not like adding the numbers, it's just putting them
Because if one
together.
overlaps in the union, you don't count it twice. Yeah.
Okay, and what you're describing, Kayla, is when you counted items, right? When we talk about the number of items. That's right. When you talk about counting the number of items in the individual sets, this wouldn't work. And this problem, actually, you're actually wanting to add the sets together. We didn't have an operation like that, did we? Union is probably the closest thing we had to that idea, but it's not the same thing. So the issue, first of all, is addition is not a set operation. Okay, it is not a set operation. But, and this is what you were kind of getting at, Kayla, but it is true that if you have the number of items in the union, and you want to find the number of items in the union, that this would be equal to the number of items in each individual set. Now, I'm not adding sets, right? I'm adding the number of items from the set. And this would hold with what is true. It does not hold in general. When there's no overlap, right. This is true when A intersect B is the empty set. If you have no overlap between two sets, right? I have this set over here, and these are my chemistry majors, and I have this set over here, and these are my education majors. Be careful, because we could have some chemistry education majors, so let's do something different. Bible, that'd be good. Chemistry and Bible. I'm probably not going to have an overlap there, okay? So chemistry, I have Bible. Then if I wanted to know how many chemistry and Bible majors total that I had, I would add up this number and this number together, because there's likely, at least in the way we're describing it, probably not that overlap we're talking about. Okay? All right, we're done on this lesson.
It was hard.